Somewhere in the Canadian Arctic right now, a cargo aircraft is making a landing that most modern regional planes are not certified to attempt. It is hauling supplies to a remote outpost, touching down on a surface that would wreck anything built in the last 40 years, and doing it profitably enough that the operator has no interest in replacing it. The aircraft performing this job was designed in 1935. Not a restored example. Not a tribute flight. An aircraft doing commercial work in 2025 on an airframe that predates the Second World War, still flying because in 9 decades of trying, the aviation industry has never built anything that does its specific job better for less money. That is not a nostalgic claim. It is a line item in an FAA supplemental type certificate. The DC-3 existed because of a phone call Donald Douglas did not want to take. In 1934, the president of American Airlines, Cyrus Smith, called Douglas and pushed him to design a wider aircraft than the existing DC-2 so American could retire its aging biplane fleet on overnight transcontinental routes. Douglas was reluctant. The DC-2 program had not yet turned a profit, and funding a new design on top of it was a risk he had no appetite for. Smith made it simple. Commit to buying 20 aircraft, and Douglas would build it. Smith sent the telegram ordering the first 10 on the 8th of July, 1935. The prototype flew on the 17th of December that year, 32 years to the day after the Wright brothers flew at Kitty Hawk. The chief test pilot later said he barely remembered the flight. It felt routine. What Arthur Raymond's design team had actually built was anything but routine, though nobody understood that yet. The cabin was 92 inches wide, the structure over-engineered well beyond what the airline's overnight route between 2 American cities actually required. American put the DC-3 into scheduled service in June 1936. Within a decade, roughly 275 of the 300 airliners flying in the United States were DC-3s. It was the first airliner in history to make money hauling passengers without a government mail contract keeping it alive. Then the war arrived and changed everything about what the DC-3 was. Military production of the C-47 Skytrain and its variants dwarfed the civilian line. Douglas built more than 10,000 military versions across 3 American plants. The Soviet Union built nearly 5,000 licensed copies. Japan built almost 500 more. Add it all together and the DC-3 family reached over 16,000 airframes. That number is the reason nothing ever successfully replaced it, though not for the reason most people assume. When the war ended, thousands of surplus C-47s hit the civilian market at prices that made new aircraft economically absurd. Some sold for as little as $1,200. Any manufacturer attempting to sell a clean-sheet replacement was competing against the United States government's own surplus stock, offloaded below the cost of building it. Douglas tried anyway. The Super DC-3, launched in 1949, was a genuinely better aircraft. Longer fuselage, more powerful engines, squared-off wings. It found almost no buyers. The surplus market had already made its decision. The attempts kept coming and kept failing in the same way. Turboprop conversions proved the concept worked but couldn't sustain a parts network. Foreign-built derivatives solved regional problems without becoming global standards. Each challenger ran into the same wall. You couldn't outprice a market flooded with aircraft the government had practically given away. What finally worked wasn't a replacement at all. Warren Basler's conversion program, launched in 1990, strips each airframe down to roughly 10% of its original metal, rebuilds the rest, fits Pratt & Whitney turboprop engines, and has the result recertified by the FAA as a zero-time aircraft. The inspection clock resets to nothing regardless of how many decades the original metal had already flown. The finished aircraft carries 43% more useful load than the original, cruises faster, and operates in environments no modern regional aircraft is designed for. In 2023, Basler's order books were full for the year. The reason all of this was possible comes back to what Raymond's team built in 1935. They over-engineered a sleeper aircraft for one airline's overnight route and produced a wing and fuselage strong enough to carry loads, engines, and avionics nobody in 1935 had any reason to plan for. 9 decades of competitors, government-funded and privately backed, piston and turboprop, never found a structural argument against that original design. They just kept finding new ways to put engines on it.